Processing. Processing.
Time is X minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
I like how
All
Jenna,
right.
you're dancing to the Adobe stock music.
It's catchy. There's a
It
reason
is.
I put
It's
it in
very-
there.
Very inspiring.
Hello,
I welcome-
everyone.
Hello, everybody. Thank you for letting us know where you're all from. And thank you so much for Troy, who's saying that they booked their vaccine appointment around us. And we really appreciate that.
Yep. I also had to move mine for the show. Yeah.
Aw. And
Yeah.
actually, John's wife may drop a child off partway through the show because of vaccine appointments.
So she can go get hers. Yep.
Yeah.
So Jenna, you
Right.
got to introduce yourself. And
Right. Yeah. I'm Jenna. I've forgotten what I do, but I do a lot. Space
You-
things.
You run the RASC top to bottom.
Run it. I think Phil's here. Don't say that. Phil runs the RASC.
That is the RASC.
Everybody else go.
My name's Samantha. I help Jenna do all the things. I help her run the RSC, but not really.
I see. So Samantha is the actual.
Samantha's
RASC.
actually in charge.
Yeah, the 10 hours a week I work. That's
Yep.
sure.
And I'm John Reed. I write books. This is 50 Things to See on the Moon, which is why you guys have me on the show here. Woo! Look at that.
Look at us with our copies of John's book.
All right. Feeling the love.
Today, we are going to be talking about Q Day -1. And the reason Q Day -1 is exciting is because it's also a day with several Apollo mission optional targets on it. And one of those targets is Apollo 16. And Apollo 16 was one of 2 missions, I believe, that landed in the mountains and on the moon, which is unusual because mountains are risky, right? Like usually if you want to land on the Maria, it's nice and flat. But this lunar mission, Apollo 16, landed in the mountains. And in so doing, it learned a bunch of stuff about lunar geology.
Was this the one that landed with a foot in the crater and it was lopsided? I think it might be.
Oh, really? Oh,
I have to look. It's pretty
Oopsie.
funny. Yeah.
well, it's a good thing they're adaptable. While you look that up, we will also mention before we launch into this, we're going to show a couple of photos of the lunar eclipse that happened yesterday morning, which is very exciting. It happened for people on the West Coast for the most part. Those on the East Coast pretty much only saw the penumbral phase, which is when it's just kind of sort of in the lightest part of Earth's shadow. And so you just see a very slight dimming and not that much. But those on the West Coast got to see a total lunar eclipse, which is very exciting. Thank you to Stephen Dow as well. Samantha's going to be showing you photos because Stephen sent in a bunch of photos of the lunar eclipse too.
Yeah, they were so cool. I had to put them all together to edit. So this is, yeah, my favorite one is it going to work? Come on, where'd it go? There, I like this one where you can kind of see how it's slowly being covered
Enters
up.
into the shadow. Very cool.
They're really cool. Really appreciate you sending them to us. I was really excited when I opened my email the other day and I was saying, we got to share these. They're awesome.
Thank you so much for sending them over. So that was really cool. We did also grab it on the robotic telescope in California. We didn't use the telescope itself. We used a camera on the back of the telescope, but we got totality here, which was very, very cool. I'm actually going to stop and share that again because I might as well share my entire screen to show you the sort of sequence leading up to it. We started with the full moon and then over to when it was somewhat covered up and then finally into the full moon or into the full total eclipse phase. And one of the kind of cool things to note about this is that in the photo of the moon when it is not fully eclipsed, either the full moon or the partial eclipse, you don't get to see the background stars. And that's because the moon's too bright.
Mm-hmm.
It would be overexposed if you were going to be able to see the background stars. Whereas with this, the moon gets really dim and you can see the background stars. So that's kind of cool.
And a really fun sort of high school geometry experiment is from that partial image, right?
Wait, hold on. Let me get it. Yeah. Ah, there's zoom windows everywhere.
From a partial
Nope.
eclipse, you can get a very rough estimate for the distance to the moon. Because if you pretend it's 500 years ago, and you know the radius of the Earth, and you can sort of project a shadow out into space, and so you can use that line and project the size of the Earth's shadow.
That's very cool.
Yeah,
it's a good point.
As a ratio of the diameter of the moon. So anyway,
it is unbelievable how much we can know just by looking at stuff. And on that note, we are going to get into I think let's do the geology side first, then we'll do targets. And then after that, we'll go into sketching after 12:30 for anyone who wants to stick around. So we know a lot, but we also don't know a lot. And so some of the stuff that we're going to be talking about today in lunar geology is stuff that we don't know a definite answer for. Like there are several theories, but we don't know which one is right. And so there is some doubt among the scientific community on some of this stuff. We're only going to be talking about one of those, and the rest of the stuff, for the most part, we know. But the one that we're going to talk about that is a little questionable is, and this comes up a lot, how come there are all these Maria, like the dark spots on the moon, on the side facing us, but not the side facing away from us? Bearing in mind that we never get to see us, human beings, standing here on Earth, never get to see the side of the moon that's facing away from us because it's facing away from us all the time.
The moon's tidally locked.
The moon is tidally locked.
No one ever had any idea until Luna 3, which was the Russian spacecraft, went there in the late 50s, what it looked like. So
I don't know why. Sorry.
Go ahead, Samantha.
I said, I don't know why it didn't occur to me that we had the far side of the moon all mapped. Apparently I learned that today. I'm a bad astronomer.
And it's, I mean, the issue being that, and this happened in the Apollo missions too, when you go behind the moon, signals can't come back to Earth. So you need to have a satellite in orbit outside of the back, like not behind the moon, for something behind the moon to talk to so that it can come back to us.
Yeah, so that's what the Chinese did when they landed on the far side, is they had a relay satellite. But for the LRO, so the LRO is a spacecraft that maps the moon, and it probably, while it's on the far side, just stores the images in memory. Because I believe that the LRO has mapped the moon down to about 1 meter resolution or something like that, the whole moon. Wow. And in both visible light and radar and all sorts of other stuff as well. So, and laser ranging, very, very cool mission. Yeah. And someone points out that it's not, we see more than half the moon. You see 59% because of the moon rocks side to side and up and down.
Yeah, so we do see a little bit more than that, but we don't get to see the whole backside, and the whole backside looks like not that. It looks like this, which is, I don't want to say it's boring, but it's not got the texture and the added color changes of having the Maria on it. There's only like this one, and then maybe this one, which John said is from a crater impact, which is really cool.
I guess that's why we call it the far side of the moon instead of the far half of the moon.
That's true. Yeah, it is the far side. Because the half would be not.
My dad's watching. He hates when people use bigger half or smaller half. So there you go.
Yeah, that's true. That's a good point. So one of I mean, if you look at oh my goodness, the zoom windows, I tell you, one of the kind of cool, like this is obviously much different from seeing the full moon face on, with the side that's facing us. We have all these dark spots, and there's all these questions in the scientific community about why there are so many Maria on this side of the moon compared to the far side of the moon. John has one theory, which I'm not sure you can explain in plain language, because I certainly didn't understand it when you said it.
I could probably do 2 of them.
Okay.
Right off the bat. And in plain language. So I guess theory number 1, it has to do with sort of tidal forces between the Earth and the moon. So you have all this lava that wants to come to the surface, that's within the moon, so molten rock in the moon. And because of tidal forces, it's sort of pulled to the Earth's side. That's really rough. I don't even know where I read that. The other one,
I've read something that says that there's something wrong with that theory, but I don't know how to put it in plain
language. They're
so
probably.
I'm not sure. Yeah.
Yeah. And then the other theory has to do with how the moon was created. So the moon was created in some sort of impact with Earth. So there was a protoplanet, collided with a proto-Earth and created a debris field, which coalesced into the Earth today and the moon. but there in the composition of the moon, you would have had some asymmetries. And so have the part of the moon was more had more radioactive elements in it, and radioactivity can create heat, which can melt rocks, which can allow more lava to bubble to the surface. And so you had one half of the moon that was more radioactive than the other, and the radioactive side gets the
melties.
Gets the melties. Yep.
Yeah.
So how did I do? Was that?
That was okay. It was pretty
Okay.
good. Yeah. So we did do a quick read of the ever professional Wikipedia article on this. But unfortunately, so this is just a quick overview of and a map of the moon as well, showing that all the basaltic areas or the Maria are all in one spot. So there are a bunch of theories listed here, but there's problems with each one potentially. And so they just mentioned at the bottom that it is still being debated by the scientific community. So we don't know this for sure. And the reason we're sharing this with you is because we don't want to oversimplify. We don't want to just be like, this is why. Because we did that, as Samantha pointed out once, with a Earth-centric view of our solar system. And we went, yep, this is it. This is the thing, everybody. It's how it works. And that was wrong. So
yeah, heliocentric and geocentric came out around the same time. We just went with one and then we were wrong for thousands of years. And look how that turned out.
Oopsie.
So we got to be careful with our theories.
Yeah, we have to be careful in how we communicate them. So we don't want to communicate to you all that this is the only option. There are a couple of theories out there. John has a question too, which is, doesn't the moon itself rotate once though every month? Yes, it does. That is what tidal locking is. So that is why we always have one face pointing to us, no matter which part of the lunar cycle it's in. Is as the moon orbits us, it have nothing round. Eraser will do. This side of the eraser is facing me. This side's facing you. And as we turn, or as it goes around us being the Earth, the moon's face always faces us. So it does do one complete turn once a month. But we only ever see one face.
Gary just pointed out that we are not actually discussing theories, but hypothesis.
Yes, that's
true.
So that's the term we were looking for earlier.
Yeah. So a theory has to have the ability to make predictions about some state of scientific method.
Yeah, these are just hypotheses. That's a very good point.
Mm-hmm.
One question from Stephen Dow: are mare from impacts or just lava filling in low areas? I believe the low areas are created by impacts, past impacts, and then the basalt filled in, or the lava filled in the low areas. So it's both. They're from impacts that then got filled in. And then one question as well from Rob Churchill: has anyone made a globe of the moon? Yes, you can buy them. I'm pretty sure you can buy globes.
Oh yeah.
Yeah.
There are many. You can download the designs and 3D print them. There's a LROC website. So if you Google LROC moon globe, it's a University of Arizona, and they have a moon globe online down to the nearest meter of detail.
Wow.
So you can zoom in and see the footprints and all sorts of stuff.
And so, yes, there is a globe of the moon. So we were going to talk a little bit about geology and just things to consider. So we have, we've already talked about some of the geological stuff too with the far side of the moon. I'm going to close that for now. Hi, Rob. Sorry, I'm not answering in YouTube. I will. I promise I'll get there. One of the things that we have a couple different targets, and we've seen these over time. We've seen craters, we've seen Maria, we've seen mountains. Mountains are one of the kind of cool ones because they are not created the same way on the moon as they are on Earth. The moon does not have plate tectonics. Mountains here are often made by two pieces of land pushing up against each other, one piece of land going under another piece of land, or land pulling away from each other and volcanoes coming up. And Apollo 16 proved that it was not volcanic. The mountains were not volcanic in origin. So it's not volcanoes making those mountains. John, do you want to mention about tectonic processes, weathering and stuff like that?
Yeah, I guess just stepping back for a minute, like what processes do affect the lunar surface composition and stuff, because we know what it's not. So you don't have these strong winds, and you don't have waves and weathering that grind down mountains and whatnot. There's different processes on the moon, and one of the you've obviously got the crater impacts that spray ejecta all over the place, and sort of the lighter ejecta is the newer stuff, because over time, you have the moon is being constantly hit by micrometeorites and solar winds, and that's what creates a weathering process on the moon. But it takes way longer than on Earth, like hundreds of millions of years, to get those colorful rays to dissipate and sort of look like the rest of the surroundings. But it does have to do with if you think about the lunar dust on the surface, like a lot of that lunar dust comes from these constant, micrometeorite and solar wind and radiation activity chipping away at all the rocks and stuff on the surface, creating this dust. And what's neat is that you do have, I forget what the average is, but there's, maybe a dozen meters of this dust above bedrock, just like here in Halifax, you dig down 5 feet and you hit solid rock, you can't go any further. But what's really neat about the composition of the lunar dust is that it increases, I believe it's exponentially with depth. So
its density increases.
Yeah, its density increases. So on the surface, like where the astronauts are walking around, they tend to sink, a couple centimeters or an inch or so. But then the density of the dust keeps getting harder and harder as you go down, which is why they can walk around without sinking like quicksand. And that was a concern in the very beginning. If you look at a lunar lander, it's got these giant feet, and they were worried about how far it would, the legs would sink into the regolith, which is the name for lunar dust. So yeah, and the way that we can sort of age things on the moon, generally. So when you have samples like from the Apollo missions, you can use dating, like radioisotope, some sort of dating where you look at radioactivity.
Yeah.
It sounds like
it's like the equivalent of carbon dating, but you can do it with rocks. So the last time that rock was in its lava form. Anyway, but because only a limited number of samples of primarily those 6 locations where the Apollo missions were, and then a few of the return missions, that's all the lunar samples we have. And so that we can age. So what you do sort of in the interim is you look at what's called cross-cutting relationships. And if you look at the moon like we have here, you can see that some craters overlap other craters. So the crater that's on top is the newer crater. And then you might have, a ravine that goes across a crater, or the crater goes on top of the ravine. And so which event happened first. And you can do this all over the place. And sort of for places that you don't have a sample from, you can then sort of fit those in the geological history of the moon by these what's called cross-cutting relationships.
And it happens all the time on Earth, because I didn't think about it applying it to the moon, but I had projects in university. If you ever drive down the highway and you see an outcrop, which is just like rocks on either side, you can see these cross-cutting happening with different colors of rocks. So this exact same thing is kind of happening on the moon. And it makes sense. It's like when you're painting, like one color is over another one, and you can know that
you can't go backwards.
You can't go backwards.
Yeah.
So that's what we're applying to this on the moon.
So there's a lot of really neat stuff we can learn. And there's also in general, like one of the kind of cool things that I think is neat is that mountains form solely because of impacts, not because of, I'm pretty sure, right? At least they're not formed because of volcanoes, which is
for the most part, I believe they're impact based. So even like those ones around the Maria, like those Maria must have been formed by a giant impact, and that,
raised up the edges. Yeah.
And raised up the edges. Yeah.
So it's super cool. I would like to climb some lunar mountains someday. Elon Musk, make it happen.
Yeah. I was like, I want to hike those.
It'd be cool.
So there's not plate tectonics, but there is tectonic activity. So you have pressure creating what's called wrinkle ridges. And like if you zoom in, that's the serpentine ridge there.
Checking for these kinds of things. Like these. Yeah. So that's like pushing up, that is stuff pushing up against each other, but it's not the plates the way we have on Earth. Those plates move around. Right. As the molten center of Earth. Anyway, cool. So lunar geology is super neat. There's a question from Joe Milbourne. Are there any analogous mare structures on Earth? I'm pretty sure no, eh?
I have to think about that. I mean, there's lots of crater impacts, especially in the Canadian Shield, where the land is the oldest on Earth.
And we do have, I think there's some like crust rebounding Because I know that happened in the Great Lakes when the Great Lakes shrunk, where the crust was pushed down and then it bounces back up, but that's not lava filling up a deep spot. And I think the only way you could really get that is when most of the planet is molten. Right?
Yeah, the crust rebounding happens a lot with glaciers. So so that not necessarily. I wonder, the only place I could think of it maybe happening, I don't know, where we have a lot of molten lava would be the Mid-Atlantic Ridge, but I have no clue.
But that's, I think, things moving apart, isn't it?
Yeah. Oh, yeah, you're right. Yeah, it's things moving apart.
And the lava comes up. So we don't have conditions hot enough to sustain molten lava just kind of like filling up an area.
I mean, maybe there were a Maria very early in the Earth's history at the same time that these ones formed. So you might have had Maria on Earth and Maria on the moon, 3 billion years ago. And then on Earth, it just got, weathered away.
Yeah.
I think our answer, we might have to do more research on it.
Our answer is
quite sure.
It's good discussion.
Yeah.
It's a good thought. Now you put it in our head. Before we go to the next question, Jenna, Troy just said that climbing lunar mountains would be cheating because there's less gravity.
Oh my God. There's this really big, long joke in the climbing community about using aid, like aid climbing with ladders and with like using stuff put in the rocks. And so that you're just saying that the lunar lack of gravity is aid. It doesn't count. I think it's allowed. I think that'd be okay. I also really want to climb. Yeah, it'd be super fun. It'd be easier, but it would still be climbing. And the risk would be a lot lower because if we fall, it wouldn't hurt as much.
And we also just got a message from Tom that said, Deacon Traps Yellowstone are late lava outflows.
Lava lake outflows?
Or lake.
Oh, are like lava.
Or late.
Hold on.
See the message.
Lacus Lake, Talus Marsh. Okay. Marsh. Okay.
One just before that.
Late lava outflows. Okay. Okay. Cool. We'll have to do more research because I don't know what that means.
And then
as good science communicators, we're not going to tell you we know things that we don't.
Yeah.
Yeah. And then John Gage asks, did the Apollo missions bring back any rock or mineral that we've never seen before? And I believe that's a yes. I've seen that in a paper, but you would have to that's something, again, we'd have to look it up because they're not things, they have complicated names. It's difficult for me to memorize it, not being a geologist myself. So, yeah. When
you say that we've never seen before, it was like material that we have not found on Earth, that sort of thing.
Yeah, I mean, it's not. For me, a non-geologist probably wouldn't find it that exciting. Like maybe we've got a rock and it's got some isotopes in it because it's more, it's exposed to solar radiation and maybe it's more radioactive, something like that. So. Yeah,
But are we talking about elements that aren't on our
not elements, just rocks.
Just
rock
rocks.
types.
Yeah.
Yeah. So there's like minerals and rock types. That are different. Yeah.
Oh yes, yes.
And
but they're subtly different. It's not like, oh my gosh, this changes everything. It's like, but that in the Avengers, like superpower rocks or something. It's like no, nothing that interesting.
No kryptonite.
No kryptonite. No unobtainium.
Yeah.
Oh, unobtainium is actually galena, and that's my favorite mineral. So I don't have a sample right by me, but it's in my bedroom. It's got a cool specific gravity, perfectly. No, we're not going to get into it.
We're not getting into it, Samantha, not this time, because we only have minutes left to cover our targets for this session. So it is Lunar Day. That's all we have for geology for now. If you have more questions, or if you'd like to get into the details of planning climbing missions to the moon, please contact us separately, and we'll get into that. And a quick last note from Dave Chapman, who says that he believes that Earth has no basalt basins because it is still volcanically active. So that's what we were talking with those plates shifting around and creating their own mountains and stuff like that. The moon has not been geologically active for a long time. Okay, let's get into targets. So we are doing our observing in the morning again this 2 weeks because that is our schedule right now. The moon was just full on Wednesday morning. And so we're heading into the waning phase, and that means that it's getting smaller and it's a morning observation. The targets here would be visible. Some of them are visible on the 31st and some are visible on the 1st. So that's Monday and Tuesday next week. You'll be able to see a little bit of this, a little bit of that. This is what it looks like from the other direction in terms of what you would see. Let's go dive into them. I'm going to show us the 31st before we look at the first. I was just about to say I'm going to show us the 31st first, which is the worst. I'm going to show us the 31st before so that we can see what we can see on this and then go into the first from there. We have the big two craters at the top, Aristoteles and Euxodus.
I call it, oh, I guess so. I always call it Exodonis, but I think I'm like mixing up all the order of the letters. I call these the bike wheel craters because if you look at it from the side, the mountain range looks like a guy on a bicycle.
And there's his little head.
There's his head and there's a bear on the back. Little bear.
Oh, little bear. It's like a kitty seat.
Yeah.
That's cute. I like
So-
that. Okay, so
Looks
look
like
for
a
the
Sour
bicycle
Patch
craters.
Kid.
It does.
Yeah.
Or a gummy bear.
Yeah, like a little gummy bear. I like
Yeah.
it.
So that's one of my favorite features. That's kind of cool. Okay.
That would be a
Mhm.
super cool one. Let us know if you agree that this looks like a guy on a bike. I agree. I think John is right.
Yeah, it
Yeah.
does.
It's never going to leave my brain now. I wanted to point out this is not a target for this week, but Posidonius looks cool. Is it not a target?
Is it?
Let me double
I
check.
say Poseidonus. I don't know who's like.
So
like,
this says Posidonius, which is why I throw in the extra I. I don't know. Poseidonus, Posidonius. I don't know. Anyway, that crater looks neat. This is tomorrow. No, this is the 31st at like 7 a.m. in Toronto. So if you want to see it looking cool, that's what it's going to
Yeah.
look like.
and then the Serpentine Ridge is there, but I don't think that's a target. Is it?
No, I don't think it is, but it's cool.
It's very cool.
And then we have, I think I missed some mountains maybe. Let me double check. Nope, we're not there yet. So in Serenitatis, which is one of the targets, we have this little crater here, which is all on its own. I think it's lovely. It's just doing its thing out in the
And
middle.
that's Bessel, the
Bessel,
mathematician. Yeah.
Oh, he's a mathematician. That's nice.
Do you remember Bessel functions, Samantha?
Yeah.
Good times. Good times.
Oh,
I was like, that sounds familiar.
I did
Yeah.
not do that.
You recognize it from the pain.
Different flashbacks start going.
Oh, it's fun. Math is great, everybody. You should do math,
Yes, I love math.
but it can be painful. We have these, which I can't get the pronunciation down. The Haemus Mountains, which are the bottom edge of Serenitatis, so the Sea of Serenity. They're a nice little, easy to spot shape because they are in between Serenity and Tranquility. So they're fairly prominent and they stick out a ways. Can't keep these targets in my head for more than 5 seconds. Julius Caesar is one of the targets that's better visible next time because it is, or on the next day. It's over here south of the Haemus Mountains. It's not a super defined crater.
I always wonder why he gets a crater named after him. Like, did he oversee some astronomers or what? What was his deal?
Yeah, seems kind of random. There he is, though. I mean, it's not a very good crater, I guess. So there's that. This is on the 1st of June, so it is better on the 1st of June. It'll be right on the terminator in the morning and easier to see. Otherwise, I think like I haven't tried to observe this one, but it looks fairly difficult when it's not right on the terminator.
Yeah, and John is asking for a sense of scale. And do you know if the lunar, does it give a diameter? So typically when you look up craters, you're given their diameter in most books and stuff. I think my book does.
So the whole moon is 3,742 kilometers across or something like that.
Yeah, so most of those craters are probably, that we pointed out, are around 100, give or take 50.
Mm-hmm.
What moon day are we on? Lunar day, sorry?
Today, this one's on lunar day -1. Nope, sorry, Q day -1.
I'm just trying to see if John's book says it.
While John and Samantha look that up, I'm going to jump on to the next target just because we are tight on time.
Most of those craters are around 100.
Perfect.
Yeah.
Thank you, John. Which is Delambre. Also one of the targets, so it's kind of right under Julius Caesar. It is also somewhat, it's not crisp, which I know is not a technical term. It's a compound crater and it's got lots of, it's got softer edges to it. And it is once again better on the, that's a lie, sort of better. Oh, hello, Edwin. Hi, Jen. It's better on the, on not this lunar cycle. So on the 31st, it's okay-ish to see there's a little bit of a shadow, but it's not right on the terminator. And on the 1st, it's already in darkness. So it's not great, but it's there for the next time that you are able to spot it. And then we have the optional target of Apollo 16, which is the one that's in the mountains. And it's, John, do you have any tips on finding this one?
Not specifically. I mean, it's always a reminder that, each pixel on here is about 1 kilometer. So you're not going to see the bottom half of the lunar lander, which is only 2 meters long. Yeah. So, but in terms of tips, oh yeah, so there's the dumbbell craters.
Yeah, that helps.
Katrina and
Cyrillus.
And so you can sort of do a right triangle up from those to that spot. Yeah.
Edwin. We have a guest.
He's
Edwin
very
wants his
opinionated
certificate.
about this. Yeah.
Um,
Edwin's gonna get his certificate. He'll be the youngest.
Yeah, youngest RASC member to get a certificate. Okay, and Marrolysis, which I didn't bother trying to find because it's in the mess of the bottom of the moon, and I'm really bad at the mess of the bottom of the moon. There it is, Marrolysis. Okay, so this is also a June 1st kind of target then. Let's see if we can find it in here.
It's quite big though, at least.
This? I think it's this.
Yeah, it looks like it.
Yeah. So it is big.
And a bunch of random things in the middle as well.
Yeah, it does have, it's a compound, and it's also got that cross thingy that we're talking about. It looks like it's almost 2 craters right on top of each other, eh?
Yeah.
That is probably the most prominent thing coming up from the bottom of the Terminator on June 1st. So that would be my best advice to get it. It's got a really bright side of its ridge here. So look for that bright spot, and that should help a little bit.
Can you go back to the, can you find it on the other view on the waxing side?
On the waxing side, yeah.
Yeah. I'm trying to think of what reference points I used.
I don't have a waxing day. Like I'd have to go and find a waxing day.
Okay. Yeah. Don't worry about it.
Okay. Yeah, it's down there. I think on the non-waxing day, at least you can see it fairly clearly. Oh, it's kind of near Tycho. It's like a equidistant from the bottom part of the moon. It's the same.
Yeah, I was gonna see if like maybe one of the scarps lined up with it and made it, so you sort of follow the line and then.
Fair, yeah.
But it looks like one of the rays. If you imagine a ray coming off Tycho and striking it.
Yeah. Following the bottom edge of the moon. That could help.
I'd reach for my notes, but I can't.
But your hands are full.
Training new astronomers.
Yeah. So those are our targets for this this week. I am going to go over and answer all of the YouTube chats now. Sorry for being absent. We also have a couple questions, and then we're going to get into sketching. And unfortunately, we do not have a choice for you today.
We kind of made a choice because we had a special guest.
We do have a special guest. That's the tiny human. John, I don't know if you want to introduce your tiny human.
Oh, yeah, I can introduce. So we actually, on Explore the Universe, we had a contest to guess his name. And the clue was he's named after a famous astronaut who is alive and a famous astronomer who is dead. And and lots of people guessed who it would be. And so he was named after Edwin Hubble, who is deceased, and Edwin Aldrin, who is still alive. But so nobody got it. But this is Edwin.
You did a good job.
Yeah, he was born right before Christmas.
Yay! Fresh baby.
COVID baby.
Fresh.
Just before we get into our sketching, I'm going to try to answer some of the questions from YouTube really quickly as well. If you're looking for where we're finding these images, everything and the things that we're showing, everything is at rasc.ca/moon@noon. So all the resources are there that you could possibly want. Oh yeah, you should nickname him Buzz. That was from Terry Doucette.
Yeah, totally.
Oh, that's so cute. And then there was a couple questions about LRO data, which I'm pretty sure is available to the public, right, John?
Oh yeah, more than you could ever imagine. So that's on just look at LROC and then University of Arizona. Just put those in 3D moon. It'll come up. It's this map. It works exactly like Google Earth, except there's about 1,000 layers of data that you can go into.
It's also linked on rasc.ca/moon@noon, so you can check that out. And then last question from Robert, am I correct in understanding that coming into tidal lock is a process? So it wasn't always so? Yes.
Yes. Yeah, it has to do with conservation of angular momentum and tidal forces bleeding off energy, bleeding off rotational energy. Yeah.
Right.
Yep.
Science.
Well, there's lots of YouTube videos on that you can check out.
Yeah, there are, and visualizations help quite a bit. If you're looking for links to some of the images that people shared from the lunar eclipse are not public, so we don't have links to those. All other images that we shared are from that dial a moon thing, or Googling what the far side of the moon looks like. And that everything else, not the far side of the moon, but everything else is posted at ras.ca/moon@noon, as well as the lunar maps showing what the targets are. Samantha made those. They're also on ras.ca/moon@noon. Well done, Samantha.
Thanks. Follow Rask on social media. I think we posted some of Stephen's photos and maybe some other images too of the eclipse. So that's where you're gonna find it, but like, yeah, nowhere to download it because property of the photographers.
Exactly. So let's get
ready.
So our target for today, which we have chosen, I'm sorry we didn't give you an option.
Edwin chose it.
Edwin chose it in honor of our friend Buzz here, who landed on the moon with Apollo 11. We are going to sketch the Lunar L, which is a series of craters beside the Apollo 11 landing site. Apollo 11 landing site is an optional observing item, I think, for Explore the Moon, which is the certificate program that we're covering. And so this may help you find it. It is not technically a target for today or for the Q day -1, but we're still going to sketch it because this is Lil Buzz's landing site. This allows us also to try to sketch a C, which I just have the hardest time with because it's a lot of shading. I know it does. It is hard.
It's so cool because there's a wrinkle ridge in the sea there too.
There is, yeah.
Frame your target.
Frame your target, draw a circle. I'm not going to because I live on the edge and because I feel like
Are you trying to be cooler than me?
I do it. Sometimes I'm just super cool. Yeah, no, I'm actually going to frame it because I definitely cannot do this otherwise. Okay, so we're going to try, I'm going to try drawing it from the top crater down. But just going over this once more for those who have not sketched with us before, we spend our last 15 minutes, in this case 10 minutes, sketching just to get some practice in. And one of the tips from various different RASC members, but this time notably the Astro Sketching group, is to lock in your shadows. So when you're actually out and sketching the moon, the shadows move around a lot, and it's easy to get confused because you'll think the shadows are in one spot and then you look up 5 minutes later and they've shifted a little bit. So what you want to do is when you're first sketching the moon, make sure that you draw the shadows or the darkest parts first.
So the way I kind of do it, I'm using my process right here, is I won't go into too much detail when I'm looking at the moon itself. I'll just kind of like scribble, okay, that's dark. And get really, again, locking in my shadows. And then I can walk away and do more fancy shading versus having my eyepiece shade. Yeah.
Can we talk about how perfect that little crater in the middle is?
It's so pretty.
It's so perfect and circular. I love it. Which I realize that all craters, for the most part, are circular. John, tell us about the non-circular craters. I think there's like 2.
Well, the most famous is that. Now I can't see it. I call it the pickle. Shriller.
Oh, Schiller.
Schiller. Yeah, so that's in the southwest, and then Messier is another one. I mean, because to get a crater to come out not circular, the asteroid impact has to come in at like a 1 degree angle, or between 1 and at least below 5 degrees. And this was they get to test this during World War II, and they looked at this the shell impacts, and like if you look at all the shell impacts, the holes are almost all round, unless the shell came in at a really, really shallow angle. And so that's
part of the reason for that too is that the craters that are made are not made by the thing hitting the Earth or the moon. It's made by the explosion that happens when it hits the Earth or the moon.
Yeah, all that kinetic energy ultimately gets turned into heat.
Yeah.
And kaboom.
Bada boom. Yeah, so that's why they're for the most part circular, even if they come in at an angle, even if the thing is an odd shape, they end up being circular. This is, I'm starting to, well, I was doing really well, I think, until I got to the bottom two larger craters, but I've been trying really hard to like get the shading right on the light side of the crater, like how there's usually shading around the edge a little bit. But I'm now not doing very well on that.
And there's a bunch of 5 kilometer wide or like 1 to 5 kilometer wide craters in there that are named after, Buzz Neal and
Are
Colin.
they really?
Oh, Judy just mentioned that. John, are you going to mention the three craters?
How big did you say they were, John?
I think they're like 2 to 5 kilometers, so just a few pixels on your map.
Okay, that makes sense. I was going to say, I thought that the International Astronomy Union was very specific about naming things.
Oh yeah, they are. Yeah, so there's 1,500 named craters, I believe.
Wow.
A lot of them are fairly recent, like since the 70s.
Okay, and I thought for the most part they were named after Greek people.
Well, so the original ones, it's a little bit more complicated than that. So the original ones were named by an Italian. I want to call him rigatoni after the pasta. But anyway, so he had a moon map and he named them sort of in chronological order. With, I think in the north you have the oldest philosophers and natural philosophers, which is what they called scientists a long time ago. And then as you get to the bottom of the moon or the south end, that's where you have more recent scientists like Newton and whatnot.
Newton being recent scientist.
Yeah.
Because he was around the time of rigatoni.
Rigatoni.
It's not rigatoni.
John, we were just talking about not spreading misinformation as science communicators.
let me see if I can open my book up here.
Is it misinformation to call a wrong name?
Yeah.
Count.
There's a Jesuit astronomer named Giovanni Riccioli.
Okay, I could see how that could be rigatoni.
Yeah.
Riccioli. Okay. Well,
and
sorry.
He died in 1671. And then so Newton was around the turn of that century. And so their lives overlapped. So he's in the very south. So up to then, you wouldn't have any scientists named by Riccioli that are more recent than that. But the IAU names craters after people that, are from this, the last 100 years as well, like Amelia Earhart. And
so I could get a crater named after me if I'm like significant enough.
Sure.
Because I thought, anyway, there's a question from Rick, or sorry, that's a lie. First of all, there's a question from Richard, which is, Samantha, could you tell us again what program you use to draw on your iPad, and show us your Apple Pencil, please?
Okay, so this is called Procreate. It's a paid app. I have a family account, so only one person in my family paid for it. The rest of us kind of just moved off that person. But it's probably the best iPad drawing app. I don't pay for a lot of apps on iPad at all. I think I have 2 paid apps in total. This is one of them. I think the other ones that I used to have a Surface Book, which is another like tablet computer thing. And I used Autodesk Sketchbook. I think it's an Adobe product, and that one was free. And you can get it both for iPad and for PC. It's basically what people usually use on PC, but this is the iPad prefer one. And I have to turn off my background.
Just put it over your face. It's okay. There you go.
This is my Apple Pencil. It's the like first generation, nothing too fancy. I have the 7th gen iPad, like the cheapest one you can get. Again, iPads aren't cheap, so I shouldn't say that. But yeah, I just use this.
It's possible given the circumstances.
Yeah, given the circumstances, considering my sister's one is the Pro, and that's like twice the cost. So, yeah. But yeah, it's got like touch and tilt support, but it's so I can shade on the edge of my pencil. But,
oh, cool.
Yeah, I do recommend if you get an iPad, like, and you want to do writing and drawing, like put out the money to get the like real one, because you get a lot of extra stuff.
That's very cool.
But yeah, this is what I draw on. I use it a lot for planning my projects, my building projects and stuff too, but I find it a lot of fun to do this.
And now I want to throw out a tip from Robert on YouTube, which is a great tip, and I had never considered it. And I'm going to try it next time. Try shading the background first. You can do it on iPad. It's by filling it in gray, and then you can do it on your sheet of paper, just with a pencil, and then use an eraser to erase the lightest bits. And honestly, that is such a good idea. I can't believe I never thought of it. That is an excellent thought. Thank you, Robert, for sharing. I was griping, and I've been griping for the whole series about how hard it is to draw light areas and like draw in negatives. So I will be trying that next time for sure. So Samantha has her drawing up, which looks
there, and I shaded in the background.
Look at that. It looks great. And you could totally add a gradient on top of that if you wanted to, because like the side to the left seems to be a little bit lighter than to the right. That would make it so much easier though.
Yeah,
Brilliant ideas. I'm going to show my drawing now too.
I'll stop sharing. Good.
What's that?
I'll
Everyone
stop
happy?
sharing. Everybody good?
I'm good. Hopefully everyone's done just sketching.
And should Edwin be the judge? So we'll see if he's.
Yeah, Edwin.
Yeah, Edwin, what do you think? What do you think? How's it look? I feel like I got better at these craters, but I did worse at these. So there's my drawing. Edwin doesn't like it. All right, that's fine. I get
Edwin, did you like mine?
Let's see. Reaction.
Wait. Oh, wait. No pen.
No.
Turn off your background.
There it is.
There
Edwin,
you
what do
go.
think?
Ooh.
Oh, he smiled.
There you go.
All
I
right.
win.
Samantha wins. As we all know,
Tough audience.
competition. Alrighty. Yeah, so wrapping up, thank you all for joining. Sketching was fun. That was a good time. I'm going to try the shading trick next time, Robert. Thank you for that. Lori Roche mentioned or asked about magnetism, magnification. And luckily you only need magnification for what you're observing and not for your drawing itself. Although Dave Chapman says that you can draw your field of view and just sketch what's in that, or to that scale if you want to, but I have a hard time with that.
I zoom in a lot. Like I can see a lot more, but I just like focus in on the one area.
Mhm.
So if you look between my observations and John, as John has like a bunch of random little craters, I only have the 2 or 3 that I'm sketching.
Yeah. It gets to be too much and it's overwhelming and it just seems like a lot if you have a big field of view. So I feel you, Samantha. All right.
Edwin,
Sorry
what do you
Edwin,
use?
for taking so much of your time up.
Okay.
All right. Thanks everybody for joining. That was a good time. We have another session next week. And then a week after that is the solar eclipse, which is very exciting. So we'll be talking about that. And then that'll be 3 more sessions total, which is crazy. We've just burned through this program. Thanks everyone for joining. Have a wonderful weekend.
Share your creations at #RaspMoon@noon. Send it to Outreach plus Moon. That way, if you have any really cool shots, that's how Stephen got it to us, his shots.
Yeah. Thanks everybody. I'm going to be working on a way to loom the moon for next time. So I'll hopefully have something to show you.